Hi, my name is Annette and this is Chemistry at a Glance. And in today's video we're going to practice some past paper questions on solid structures and their properties and smart materials. And these are our questions. So let's start with the first one. Both sodium chloride, and before we start, also if you don't know much about this topic or want to revise this topic, I encourage you to visit my blog where I go through exactly what I did to prepare for my exams and how I revised for my exams. So please visit there. I leave all the links in the description box below as always. So both sodium chloride and cesium chloride have giant ionic structures. Draw a labeled diagram to show the arrangement of ions in a crystal of cesium chloride. So cesium chloride is a body-centered shape. So I'm going to show you how I draw it. I always do like a box first. It's not going to be perfect. I never draw my drawings perfect, but we draw a box first. And these lines, yeah? So this is our 3D box. Now we have one chlorine in the middle. This big one is our chlorine minus. Oh, sorry. No, the other way around. We have cesium in the middle, and it's a plus, and then we put 8 chlorines outside. Because it has a coordination 8 to 8, so 8 chlorines fit around one cesium ion. So we have cesium plus at the beginning, 8 chlorines outside. That's just something you have to show, like it's a box, we have cesium in the middle, and then 8. Okay, next part. Give a reason why sodium chloride has a different shape from cesium chloride. So, sodium chloride is a face-centered. And it's a quite different shape than cesium chloride sodium is. And this is because sodium chloride has a coordination number of 6,6 and cesium chloride has a coordination number of 8,8. What the coordination number shows us is that around cesium we can fit 8 chlorines, and around sodium we can fit 6 chlorines. This is because sodium is smaller than cesium. And this is basically our answer. Cesium is bigger than sodium and can fit more chlorines around. This is all we gotta know. The next part says that diamond and graphite are 2 different crystalline forms of carbon. So both diamond and graphite are formed of carbon and nothing else. Describe the structure and bonding in both diamond and graphite. So let's start with diamond first. So in diamond, each carbon is covalently bonded to 4 other carbons. This gives us the 4 bonded pairs, no lone pairs. This gives us a tetrahedral shape. We covered the shapes of the atoms in a previous video, so you're invited to watch that video first before that one, or read the post on the blog, or if you know it, just carry on. Graphite, on the other hand, 3 or 4 carbons are bonded covalently, and the electrons from the 4th carbon are delocalized in the system, and the planes of these carbons are held together basically by van der Waals forces. this is the overall of what you need to know about diamond and what you need to know about graphite. So graphite can slide over each other because it has the localized electrons between the planes of graphite, and the planes are only hit by weak van der Waals, so it's easy and soft. Next one. State one physical property that is common to both diamond and graphite and one that is not. Relate both properties to the structure and bonding you have described. So, what we can say is that they both have high melting point. And this is due to the covalent bonds. They're difficult to separate. That's why they both have the same, not the same, but high melting point. The thing that differentiates between those two is that graphite conducts electricity. It conducts electricity due to these delocalized electrons. They can move and carry the current. While diamond doesn't have that because 4 of 4 carbon atoms are just covalently bonded to each other, so it's a solid. Next question says both iodine and diamond contain covalent bonding. Explain why the solid iodine can be converted into vapor at a much lower temperature than diamond. So with iodine, it's all about iron and iodine bonds together to form I2 molecule covalently. So this is a covalent bond. However, when these I2 molecules bonds with another I2 molecule, they actually bond only by the weak van der Waals forces. However, diamond, as we just said, has very strong covalent bonds between carbons, is strong. So it needs much more energy than iodine molecules because the iodine molecules only have these weak van der Waals forces. And this is our answer. As you probably know, the intramolecular forces, so covalent bonds and ionic bonds, are stronger than hydrogen bonds, and then hydrogen bonds are stronger than van der Waals forces. So van der Waals forces are least strong. Next question says an element has a melting temperature of 28 degrees Celsius and conducts electricity when it's a solid or a liquid. State the feature present in the structure that allows it to conduct electricity. It conducts electricity when it's a solid or a liquid. This means that it's not about the ions, because if there were ions that can conduct electricity, that can carry the current, they will only do that when they were melted. So when they were a liquid, because if they will be a solid, they will be hard, they would not be moving around. So the only other reason why the structure why the element can conduct electricity is because it's a metal. And in metallic bonding, we have this C of the localized electrons because the elements donate their electrons to the C of the localized electrons, and that's how they bond. So they can conduct electricity because of the C of the localized electrons in metals. So the next question is very simple and very short. Describe the structure of sodium chloride. So our sodium chloride, the one we just talked about. So each sodium is surrounded by 6 chlorine ions. It is a lattice, and lattice means the Na and Cl, never mistake this, Na and Cl, they're not bonded together. They are held in lattice by some type of bonding, but they're not actually bonded together, ionically, covalently, nothing. They're just held together in a lattice. So, we also know it has a face-centered structure. If you want, you could even draw the structure out. And it has a coordination number 6, 6. 6, 6 is because 6 chlorines surround each sodium, and this is also the other way around. Each chlorine is surrounded by 6 sodiums, and so on, so on, so on. Next question says, draw a section of sodium chloride lattice and state where sodium and chlorine atoms are present. So, we drew the structure of cesium chloride already, and you know I started with a box. This time it's exactly the same. We start with a 3D box. So after you draw your box, this time it's face-centered, no, not body-centered, so we don't have an atom in the middle. It's surrounded by 6 atoms. So we draw these big and small circles. And as you can see, we've got 1, 2, 3, 4, 5, 6. The big ones are our chlorines, and the small one is our sodium. So as I told you, each sodium is surrounded by 6 chlorines, and each chlorine is surrounded by 6 sodiums. So we've got 6 sodiums surrounding the chlorine. And then if we have a sodium right here, we have 1 chlorine, 2 chlorine, 3 chlorines. And if we wanted to draw, we could also draw, because this is just a part of it. So if we drew it more and more and more around, they would all have 6 of each around each other. So 6 sodiums around chlorine and 6 chlorines around sodium, and so forth. Next question. Explain why sodium chloride is soluble in water. So it's easiest to explain if I just draw it. We know that water molecules are polar. We also know that sodium chloride is an ionic. They are ions, sodium and chlorine atoms. They all ions. They all ions, as in this one, the ions. So any plus ions are actually attracted to the oxygen minus, because in water they kind of separate. So sodium chloride in water, the ions kind of separate and connect to water. So negative ions connect to positive H in water, and positive ions connect to negative O in water, and that's how they're soluble. Why is graphite soft? Graphite is soft because, as I told you before, graphite consists of layers. And between these layers, we only have weak wonderful forces and the electrons, the localized electrons. So the layers of in graphite slide over each other. So when they slide over each other, this means that the graphite is soft, because when we touch it, the layers slide so it can move. And the last question, describe the structure and bonding in diamond and calcium metal. Relate the electrical conductivity and melting points of each to the structure you have described. So let's start with a diamond first. What can we say about diamond? So we know diamond is a giant molecule. We also know that each carbon is bonded to 4 other carbons. We know that it has strong covalent bonds. What we're doing is describing the structure and bonding. Oh, and this bonding is covalent. And then relate these properties, these structures to electrical conductivity and melting points. Oh yeah, strong covalent bonds. This is the structure and bonding of diamond. Due to these covalent bonds, diamond has a high melting temperature. It needs a lot of energy for these covalent bonds to be separated. However, diamond is a strong solid molecule. It has no electrons flowing around, it has no ions flowing around, so it doesn't conduct electricity. Calcium metal, on the other hand, we are told it's a metal. We know there are metallic bonds between two calcium metals, because metal and a metal, it's a metallic bond. And we also know that in metallic bonds, the atoms donate the electrons to a sea of delocalized electrons. What this means, that the nucleus is attracted to the sea of these delocalized electrons, because you know nucleus is positive because we have protons in there. So these electrons in the delocalized system suggest it can conduct electricity. Electrons flow, they can carry the current, so they can conduct electricity. So this was all for today. Remember, everything I show you are my techniques and ways of learning and revising. If you have any other questions about my videos, please comment or email me. I leave all the links in the description box below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. Thank you. And it would mean a lot if you could like, subscribe, and see you soon. Bye.